Steve Getau 3660. In our today's lesson, we shall look at preparation of oxygen gas and some of its properties. Now, this is a continuation of the series of lessons that we shall have on preparation of gases and other experiments done in the chemistry laboratory. Welcome to the lesson, and let us move on. The first item is to look at what reagents we shall use for this experiment. We shall need hydrogen peroxide. We shall need hydrogen peroxide. We shall need a catalyst. Our catalyst is manganese 4 oxide. Right, and in terms of the apparatus that we shall require, we shall need a round bottom, a flat bottom flask, or a conical flask can also do. We shall need a drop-in funnel, and where a drop-in funnel is not available, we may use a distal funnel. We have improvised a distal funnel such that we shall be able to regulate, or rather, we shall be able to ensure that the oxygen gas does not escape. We have a trough of water, and in this trough we have either a gas jar. In this case, we have also improvised to use a measuring cylinder. For testing the gas, we shall test it by first of all correcting it in a boiling tube. So here we have some boiling tube. We have boiling tube which we shall fill with water and then use them to collect our gas. So with that done, we are ready for correcting the gas. And the first thing is we're going to add the manganese 4 oxide into the conical flask. So using a spatula, let us add some catalyst, the manganese 4 oxide here. That is the color, a black powder. We add a good quantity of it into, that's enough. We tighten this portion. We tighten here so that we ensure that no gas leaks out. We'll be able to collect as much gas. And viewers, one precaution that we need to be careful about is, as the gas comes out, the first few bubbles should not be corrected, as they will be mixed with the air or the mixture of air that is available here. So we shall let out the first few bubbles to escape into the air. The next part will be to add the hydrogen peroxide, and the moment we add, we should be able to expect the bubbles to come out. So let's add the hydrogen peroxide. We add enough of it. Okay. You can see some bubbles. So that's enough. And we have let a good volume of it, so we collect our oxygen quite fast there. The first jar is already full, the first boiling tube is full, quite fast. So we correct the second one, and we need to cork. So let me return that, it has been exposed. So we cork. I put it in my rack. Put it in my rack. We correct the second quite fast there, moving very fast. We correct it also. And this time round, I will use the measuring cylinder, which, there we go. We are correcting the gas. As you can see, the oxygen is colorless. The oxygen has no particular color, so we say is colorless. We shall be able to do some other tests for it. So I'm going to ensure that no, let's repeat on that one. Let's repeat on correcting it in the gas jar. So some of it escaped. Let's do it again. Very good. We fill in it. Fill it very fast. Very well done there. So I will ensure that no air gets in there. We've done it underwater. So that gives us a very good correction of the gas. And I would like us to move straight away into testing this gas. So we are going to test this gas, and when we are testing oxygen, we use a glowing sprint. We use a glowing sprint. So let's get I try myself there. We're going to get one jar, preferably one boiling tube, and this is a burning sprint. We are not going to use a burning sprint, but a glowing sprint. I will be closer to the camera, and we're going to open and let in the glowing sprint. So I put off the flame and we dip it in there. Very good, magnificent. So that is it. We do it once more with the second jar. We can repeat on that one. You see the second jar. Slowly, we do it again. We may use the gas in the gas jar. So I create a glowing sprint, enough of it there. So not enough, let's get some more. So that is enough. So let's go. We dip it in there. Great. You can see. Can repeat on that. And see, it relights a glowing sprint. So that is very, very important. That the magnesium, the wooden sprint, when it has a glowing point like this one, the glowing sprint, then when it's inserted into this, then we are able to have that kind of a reaction. So that is extremely important as the test for oxygen. So very quickly, let us go through some of the properties that we have discussed and see some of the reagents. Number one, we've talked about the reagents, hydrogen peroxide and manganese oxide as the catalyst. So the chief reagent is hydrogen peroxide. It undergoes what we call decomposition. It breaks down into the two, water and oxygen. Now, what we've talked about the apparatus, the drop-in funnel, the flat bottom flask, the delivery tube, trap, beehive shell, and the gas jar. That kind of a setup. Number three is the equation for the decomposition of hydrogen peroxide. We have the hydrogen peroxide as our chief reagent. It is decomposed and the reaction is made faster by the catalyst, manganese oxide, to produce water and oxygen gas. How do we correct this gas? The mode of correction is by downward displacement of water. The oxygen is corrected by downward displacement of water, also known as the overwater method. Now, item number 5 is we investigate some of its properties. Number 1, in terms of properties of oxygen, we find that it is colorless, no particular color, and also odorless. It has no particular odor. 2, it is slightly soluble in water. What does that one mean? Only a small portion of it can dissolve in water. So, slightly soluble in water. You can recall that fish and other aquatic animals are able to survive in water. They use the dissolved oxygen. So that is the point we are making there. We also need to look at the test for oxygen gas. We test using a glowing sprint. I would like us to see the difference between a glowing sprint and a burning sprint. The burning sprint has a flame. The glowing sprint is hot, but there's no particular flame. What happens? The glowing sprint relights. It gets the flame back. Other times we say it is rekindled. So oxygen relights a glowing sprint. In our earlier experiment on hydrogen, we saw that hydrogen burns with a pop sound when a mixture of oxygen and hydrogen is brought near the burning sprint. Other methods of preparing oxygen in the laboratory. Number 1, we have the reaction of sodium peroxide with water. Viewers, I'd like us to note that it is sodium peroxide. The catalyst there is, or the reagent there is manganese, the reagent there is hydrogen peroxide. Here we are talking about the reagent sodium peroxide with water. So this will generate oxygen gas and sodium hydroxide. We may also heat potassium manganate, also known as potassium permanganate. Potassium manganate 7. You heat it strongly and it will decompose to yield some manganese oxide and some oxygen gas, which you correct. Now, the last item that I'd like us to discuss is, in life, what are some of the uses of oxygen? Oxygen is used in hospitals to assist patients with the breathing problems, respiratory challenges. So we say air enriched with oxygen is used in hospitals by patients with breathing difficulties. Number 2, we also have deep sea divers and mountain climbers. They dive and they climb the mountains with tanks, small cylinders filled with the oxygen to assist them, because deep sea divers, when they dive so deep in the sea or in the oceans, the oxygen levels are very low. The same case up in the mountains. We also have oxygen being used in oxygen acetylene frame. This is a frame whereby acetylene is mixed with oxygen and then burned at a torch to assist in welding and also in cutting metals. So viewers, we've come to the end of our lesson today, and I do thank you for joining me in this lesson. We have looked at preparation of oxygen, and I pray that join us in our next presentation, whereby we shall look at preparation of another gas. Do share, subscribe and comment so that we grow the channel. Thank you, and let's meet next time.